Lesson 4-6. Let's start with one of the vocabulary words and kind of the main idea. They give you the word relation. And in this case, relation means pairing numbers in one particular set with numbers in another set. And then I kind of created like a flow chart. The first set is called the domain. The second set is called the range. You've actually worked with this already with other words. The first set is the x values. The other set is the y values. Or, to use some other words we've already used, the first set is the input. The second set is the output. So a relation is pairing numbers in one set with the numbers in another set that creates x values and y values. From this point on, domain is going to mean x values. Range is going to mean y values. So when you have an ordered pair that you're graphing, you could call the x value a member of the domain of that set. You can call the y value a member of the range of that set. Why do we have so many words that all mean the same thing? I don't know. Why can the Eskimos describe snow with so many different words? Now, this is going to be important. A function is a specific kind of relation where every single domain value, every single x value, is paired with only one range value. For every single x, there is only one y. Notice that I'm not saying the opposite of that. For every x, there is only one y. Take a look at problem 1 on the bottom of page 268. So they have given you a set of ordered pairs. That's much easier to read. Here's set A. Your pairs are -2 and 0.5, also 0 and 2.5, and so on. They've picked out the x values to give you the domain. They've picked out the y values to give you the range. And then they have created these two columns. Here are all the different numbers in the domain. Here are all the different numbers in the range. And this fits the definition that I just read to you a couple times. Every single domain value is paired with only one range value. This 0 is paired only with 2.5. This 5 is paired only with 2.5. That's okay. This relation is a function. Now, take a look at letter B. They've given you 4 ordered pairs. They've pulled out the unique domains. There's 1 6. There are 2 6s. They only had to list it once. There's 1 4. There's 1 5. 4 ranges. And when they list them, 4's got only one pair. 4's got only one match. 5's got only one match, but 6 has 2 matches. So you cannot have something in the domain that has 2 matches. So this is not a function. And that's all they want you to be able to do to use these mapping diagrams for Got It number 1. So in Got It number 1, you should end up with a list kind of like this. Domain with the numbers that were x values, range with the numbers that were y values, and you see it right away. 4.2 is matched with 2 range values. So this is not a function. Let's see what happens with letter B. Every domain value has only one range match. So that one is a function. There's another way you can check to see if a relation is a function. It's called the vertical line test. And basically, if you plot the numbers that are given and imagine drawing a vertical line through each point, well, if you have a vertical line that goes through more than one point, that's not a function. So these collection of dots doesn't work. But take a look at letter B. They've given you the function, they've shown you the graph. You don't have to do much work at all. Now imagine that you draw a vertical line through every single point on this graph. Are you ever going to cross the line more than once? No, you're not. So this one is a function. Check out the difference. 2a, your graph should look something like this. I plotted the points they gave, and if I start drawing vertical lines, each vertical line I draw goes through only one x value. So that one is a function. Take a look at letter B. Here is a point, here is a point, here is a point. There are 2 points on the y-axis, which means there's a vertical line, 2 points on it. That one, not a function. So this actually highlights a math question that I've had for years. I didn't put this over with the other vocabulary. Something called function notation. Instead of saying y equals whatever your function is, you can say f of x equals, and that's how you read this. You say f of x equals. This doesn't mean some variable f times x. This is read as the function f of x instead of y equals. Usually they use f, sometimes they use g, sometimes they use h. There's really no rule. In problem 3 they go on to use w of x, and yeah, I don't know why they do it this way instead of just saying y equals. That is for keener math minds than mine. Although if anybody wants to look it up and show it to me, I'd be happy to give you some bonus points for it. All right, before we get into got it number 3, let's go back to the book. So they've given you a fairly straightforward function. They could say y equals 250x, but instead they chose to say w of x equals 250x. And then they explain what the function is, and they want you to figure out how much you can read in 8 minutes. And then look here. They start off writing the function w of x equals 250x. Then when they go to plug in the 8, they put the 8 in here and they put the 8 in there. All this means is w of 8 equals 250 times 8. Notice that it stays w of 8 when you get to this last step. And that's your answer. W of 8 equals 2000. So for problem 3, they just want you to use that same function you were just working with, but find out what you can read in 6 minutes. I think they just want you to have some practice working with this unusual arrangement. So you need to write down w of 6 equals 250 times 6. Do the math. There's only math to do on this side. There's nothing to do on that side. And that's it. There's your answer. So problem 4, they want you to find the range of a function. Remember, the range is the y values of a function. So this only works if they give you some specific x values, and sure enough, they do. They say here's the domain of this function, and this one you'd read as f of x equals that. That set makes up the domain. What does this mean? This means make a chart. Here are your possible domain values. 1, 2, 3, 4. Here is the function that you're using. So when you plug 1 into the function, you write it in, plug 2 in, so on, and here is the answer. When you plug 1 in as an x value, f of x is 2.5. And those are your other values. Since these are the only domain values of the function, these are the only range values for the function. And they show you the range is, notice they've written it in set bracket notation. And for number 4, they want you to try your own. They've given you the domain of g of x. Those are the points you need to put in. Here is the function. You need to create a table that looks just like this one, only, with this function and those numbers, and figure out the range. So your chart should look very much like this. Check this with yours. Make sure you didn't make any silly math mistakes like I did. And your final answer says, in set notation, these numbers, okay, the range of g of x is that. All done. So now, after all that we've been through, they want you to start doing reasonable about domain and range. Oh, crazy. So you've got 3 quarts of paint to make the trip. One quart covers that much, and they're given the function a of q equals 11q. What domain and range are reasonable for the function? Basically, they want you to think through. Are you going to put negative numbers into this function? Are you going to have negative quarts of paint? Is the paint going to cover a negative area on your house? No. If you only have 3 quarts of paint, are you going to see what the function generates if you have 10 quarts of paint? No, that doesn't make any sense either. So basically, the domain for your function. So your domain in this case is going to be from 0 again, but you can go all the way up to 7. So to try and figure out the range, we already have the range for using up to 3 quarts of paint. So just try one more number. Here's the function we were given. Put 7 in, because that's our maximum value, our maximum domain value. A of 7 equals 700. So the range of this function, if we have 7 quarts of paint, is from 0 all the way up to, that's a 700. And letter B is just a thinking one. We've kind of been talking about it as we've gone through. Why doesn't it make sense to have a domain value less than 0? Because you can't use negative amounts of paint. All right, we have made it to the end of another thrilling lesson. Do the lesson check on page 271, and I will see you tomorrow.